Well, hello everyone, my name is DDevelops, and if you're watching this video, I think you already know that, and if you don't, well, that's my name. And I just completed my uh, Bachelor of Science in Biotechnology, and I had been thinking, obviously there's a gap between me deciding what I have to do next, obviously masters, but where, when, how, that's all, in the works right now. So it's like, well, I should not waste time because, well, time is of the essence here. That's somebody, and time is also money, and I'm broke as so basically what I was because the thing is key. I want to do something in bioinformatics because bioinformatics really intrigues me in the sort that was when I was young, what, 14 15, my uncle, who is a computer engineer, he taught me how to code, a software engineer specifically. He taught me how to code in C, and I was like, that's cool, we can tell the computer to do things and then it does the things. Then I learned Python on my own when I was in what, 11th. Then I wrote code until 12th. Then I also learned C sharp, and I made games in Unity. But then all that stopped when I joined college because there was no incentive for me to do it because I had already other things to do and I did not have time to write code. But bioinformatics, we were taught bioinformatics in the course, but there was nothing that was actually hands-on. Bioinformatics was actually us using tools. But I think bioinformatics is more about, I not that's my opinion actually, in a sense ki we should be learning how to build tools or how those tools work, because even then it just becomes an application, and yes, that is more accessible to people. But as scientists, if we are not getting how the things actually work, then, and I know that in BTech, BTech biotech, they might be teaching all those things. I don't really know, but so that's why. So now that my degree is over, I have plenty of time, at least for some months. So I was like, I should do something. I should learn the bioinformatics, the programming problems of bioinformatics, and what, are the what's the logic with all algorithms at all go into bioinformatics. So I was looking on Reddit for something, course of sorts that taught me all that, but like suggestions from people. Obviously, I was not looking for a course on Reddit, but so then I came across this platform called Rosalind, and that is basically for it's a lead code type platform, but with bioinformatics problems. And I was like, why don't I solve this? Because I like solving problems, I like puzzles and all. But the thing about me is I'm not very accountable, and I procrastinate a lot. So I decided, what if I make videos solving these problems? Somebody out there might be helped by it. But the thing is, there's certain things that I want to make clear, is that it's been 3 years since I have coded anything in Python, and the last level of proficiency that I was somewhere between beginner and intermediate. So I still don't know a lot about Python, and obviously I can just say I'm a beginner right now because I only know the logic and so the basics of it, because the knowledge that I had has deteriorated because I didn't code anything in the period of 3 years. But now I'm very enthusiastic to start. And the thing is, in Rosalind, you can use any language you want. The thing is, it only takes in a data set. The answer. It gives you a data set and it only takes in the answer. So without any further, I've solved two of those problems, but I have not submitted them yet. Let's see. So this is it. I did submit them, but with not this account. Obviously, I was like, I should start anew. So the first problem over here is it also has given us a certain molecular biology introduction, and that's all we should be concerned with because I already have a degree in biotechnology and I know the basics. I'm not boasting or anything, but yeah. So now the thing here is the problem is a string. It's giving us a definition of the string, but yeah. So there's a DNA string that has A, C, G, T, and we have to count the number of times A, C, G, T. Okay, so it's basically we have to count bases. Okay, so I'm just explaining the problem. I've already solved it, but now we're gonna submit it as well. So the logic behind this is that I've solved two of them. We're gonna solve the third one in this video. So the first one here is count bases. So I do this first. I open the file because it gives the data set in the form of a file like this, Rosalind DNA.txt, and then we read it. That's the mode that I open it and that's then we read its line. I'm not explaining the entire code. Again, this is not a tutorial of sorts. It's just like a log. It's a learning log of sorts. And I think the people who already know Python and are interested in bioinformatics should watch it. Or maybe you should just watch it if you are trying to do bioinformatics and Python by your own. So it just we just use this method or function. I don't know what you call it because I think about thing about Python and how I learned it is I learned it intuitively through projects, and I don't know what is called what. I just know how it is used, and I think that is dumb. It's like not knowing the grammar of your own mother tongue. It's like that. But yeah, that's dumb, but still, that's how I've learned it. So then this function actually reads the file and stores the lines in a list. And the first item on the list is the entire string that was in the file. So now the order that we need to read the output in the number of times is A, C, G, and T. So we just use the count method on that string that we got from this file, and we just count all of them and we just print them all together. So now let's go over here. Let's download the data set, and okay, the data set is here. So now let's pick this up, control X this, and let's go over here in the directory of our, and we should replace the file in the destination. And let's run this code. It will take that, and now we have the answers right over here. We'll go over here in Rosalind and we'll paste our answer over here, and let's choose submit. We can also paste it, we can also submit our code. But yeah, so congratulations, I solved this problem. Yeah, I already know that, I already did solve it. Okay, now the next problem is transcribing DNA into RNA. So basically, an RNA string has uracil instead of thymine, which is the U instead of a T. So it gives us this entire string. You can see there's T's in this DNA string, and all we have to do is just change the T's to the U's. This is also a fairly simple problem. Let's just go through the code. Replace thymine. That's sort of calling it. So just open it, read it, and we just use the replace method on the string that we get, and we just replace the capital T's with the capital U's, and then we print it. So now let's again go over here and let's just download the dataset, and let's go over here. We should rename this, delete the previous one, and we should just rename this to, and control X this, and let's go over here, amplify, then paste it over here, paste the file in the destination. Now that we've done this, let's go over here and then let's run this piece of code, and we have the entire string. We just copy it and we paste it over here, and then we choose submit. Yeah, now we have also completed this thing, and now let's move on to the third problem that I haven't solved. So yeah, okay. In counting nucleic acids or double helix, the thing that I like about this is it is also giving me primers on the theories behind the problems, I think. And this is sort of giving me a refresher of what I learned in my bachelor's degree. So yeah, the secondary and tertiary structure of DNA. Let's not focus on the theory right now. So now let's see what the problem here is. In DNA strings, symbols A and T are complements of each other. That is, adenine binds with thymine. So in this string here, these are two strands of DNA. If there's an A over here, the opposite will always be a T, and if there's a G over here, the opposite will always be a C. That's how they bind to each other. That's why they're complements of each other. The reverse complement of a DNA string is S of S. DNA string S is S. C formed by reversing symbols of S, then taking the complement of each symbol. So basically, what we are doing is first there's G T C A T G A C. Hmm. Wait, that does not make sense. Complement is a G. There should be C over here. There should be A. Okay, okay, I got it. So what we're basically doing is we are reversing the string. Reversing in the sense that we are if we are like, for example, this at where should I type this? Okay, there's no place for me to do, so should just open notepad. Yeah. So okay, so for example, if there's a t t a g c, and the complement of it would actually be TATATCG. But that's not what we want. We want a reverse complement. So in a reverse complement, what is basically happening is, in a reverse complement, what is basically happening is we are reading it from the back, like reverse sing the string. So we're not going from left to right, we're just going from right to left. So we are reversing it. So it becomes CGA, what the fuck, CGA TATA. This is what it becomes. Okay. And then we make a complement of it. So GCTATAT. This is a reverse complement. Okay, reverse complement. And this is a reversed. And this is the original. And this is just a complement. Okay, so this is basically the logic behind this. So I think the logic is very clear what we have to do. First, we just take the first we just take the this string. We first reverse it, and I think we'll use a reverse slice to do that. Reverse slice, basically we are moving from the end of the string to the front. So first of all, I think we'll need to copy, third problem, we'll need to copy this because we need to read the file. So I'm just reusing the code, and we'll change the name later. So now that will contain our main string, right? I've got a bit of code, so yeah. So now the first thing that we need to is reverse the strand. So what we will do is, now again we just make changes to detail, and then we do this reverse slice. Okay. So now, for example, if we print detail, you'll get to know uh, uh, print dt. I'll show you guys what I mean by we'll just first dt is equal to atgc. Okay. Now I'll show you guys what I mean by, see, now it is CG, like it just went from the back, and it's TATA. So now that we have reversed it successfully, now we need to complement it. So in complement, we just basically need to replace all the complement. So if you want to complement this, how will we go to about it? We've already used the replace function over here to replace certain things. Okay, so I think we should just use that. So dt equals dt dot replace first we replace all the t's, all the a's with t's, and then we use a nested approach to replace all the t's with a's, and then we again replace all the g's with c's. Okay, c's, and again we last nest all the c's with g's. Okay, and we just print this, print dt again in order to check the output. But I think we need the sample dataset from here in order to just see if it works or not. So again at the start we'll just add a line, we just change the value of this to this, and so we've reversed it over here. That was working, and let us complement it. Okay, now that's not what we expected, right? It should be, what the fuck. Oh fuck, that is dumb. So the problem is that is happening over here. I've got it. Is that if we are changing the A to T, and then we are again changing the T to A, we're changing the G to C, and then we're again changing the C that we've already converted into G. So there's no way of differentiating between ones that have already been changed and ones that have not been, ones that have. I have so the way we will do this is we first replace all the A, but if we uh, maybe we oh, I know exactly what to do here. Okay. So earlier when I was doing this replace time thing, what I accidentally did was I instead of capital T over here, I this U was okay, and if I instead of a capital T over here, I added a lowercase t over here, and it did not work because there was nothing in there. But I think we can use lowercase here to differentiate between the ones that have been changed and ones that have not. So if we change all the capital A's into small t's, they will not be changed by this nested replace because well they are not the same, and we will change all the capital T's with A's, small A's. Actually that should not matter anymore because we're not again doing anything, so we could keep that as the same. But yeah, let's just change everything to lowercase, and then this G becomes lowercase c, and this becomes lowercase g. So now they are all being changed into lowercase, but we are differentiating between them because all we are replacing are the uppercase ones. So that would happen. And again, in order to just get the final output, we'll all change it to upper. So I think that should do it. A C C G T A C C triple G 40. Okay, we have done that. We have gotten the answer. So now let's just we'll remove this line. Okay, and okay, now that's okay. Now let's just download the dataset and submit the problem. Okay, now we've gotten that. Now let's cut it and let's go to this open an explorer, and let's go here. We just paste it over here. It's Rosalind underscore RVC. So we just change the name REVC. Okay, and now let's just do it. And I'm not sure if it has worked or not, but let's just paste it and let's know if it worked or not. We've done that. So like that we've solved three problems, and the next problem is rabbits and recurrence relations, and that looks like a hard one actually. So I think we'll see this in the next one, and I'll study the problems and I'll try to become a better programmer and then not have a shitty logic, actually a better bioinformatician, and not have shitty logic in my programming, and I'll try to brush up my skills again. So if this log, the log, that's what I like to call it, a learning log, was fun for you, maybe you should go ahead and try this out as well if you are interested in bioinformatics and programming. If not, well, just have fun and share it to somebody who does like bioinformatics. So on that note, and if you have any constructive criticism, and I really mean constructive, do not hesitate to put that in the comments. And on that note, I'm ending this video. Bye. See you while I solve the next problem, which will be soon.